Okay, with graphing radical functions, we're going to look at square root and cube root functions and their transformations. So, if you think back to when we did, I'm going to do it in this corner because this is about the only space that I have. But when we did f of x equals x squared, and we just did quadratic functions and their transformations, okay? I did a parent function table. Do y'all remember what our x values were?
-0.
Very good. And then our y values, we found our y values from squaring all of those x values. So -2 squared would give me 4, -1 squared would give me 1, 0 squared would give me 0, 1 squared would give me 1, and 2 squared would give me 4. And our graph would look like this. It was a parabola for quadratic. Okay. So what we're going to look at is the square root of x. How is the square root of x related to x squared? It's how you undo it, right? You would square root an x squared and you could undo it. So that's called an inverse. Okay, so the x squared and the square root of x, these two functions are inverses of each other. Okay, so every time we've done transformations up to this point, our x values have been the same: -2, -1, 0, 1, 2. Okay, so when we go and do our parent function for the square root of x, can we have the same -2, -1, 0, 1, 2? So think about what you're plugging in a x value. You're plugging in x, and that's how you get your y value. So if I do a -2, what happens if I take the square root of a -2?
It no real roots.
No real roots. It's imaginary, right?
Yes.
So would it make sense to have -2 and -1 on my table?
Yes.
Would you just tell me there's no real
But
roots?
okay.
So x squared, I can take any positive or negative and square it. Okay? I'm taking the square root. We've learned that when you take the square root of a negative, it's imaginary. Are we going to be able to do imaginary on this real xy graph?
No.
No. So I'm not going to have -2 and -1 on my x values. Okay? Can I use 0? Okay, if I take the square root of my x, that means I'm taking the square root of 0. What's the square root of 0?
0.
0. Can I do 1?
Yeah.
Yeah, what's the square root of 1?
1.
Good. Now, am I going to use 2?
No.
Why?
Because there's no square root.
It's a decimal. So, what would my next value be?
4.
4. Okay, so if I take the square root of 4, what does it give me?
2.
2. What's my next value?
9.
Square root of 9.
Right.
So what are we doing here? What are these numbers? Perfect squares. Because what you're doing, you have to plug in a perfect square to take the square root and get a whole number. Okay? So if I kept going, I would need 16, but 16 isn't going to fit on my graph. So for our parent function for square root, you only need 0, 1, 4, and 9 for your x values. That's different than what we've done in the past, so you're going to have that down. Okay, and then when we get to cube root, it's going to be different. So you're going to have to separate square root and cube root when you do your worksheet and your quiz and your test. But on your test, you have note card, right? That would probably be something that I would put in the note card. So if we are graphing this, I've got my 0, 0, my 1, 1, 4, 2, and 9, 3. Am I going to extend the left part of my graph with an arrow? Why not? Okay, am I going to extend the right side of my graph with an arrow? Yes. Why?
Because it's infinite.
Because you can keep going and you can do the 16 and you get 4, you get 25, and you get 5. So this, as far as we know, right here, you keep going on for infinity. Okay? Now, what I'm asking you is, do we go past the 0, 0?
No.
No.
Can't, because those are.
Okay, because that makes me take the square root of a negative, which is imaginary, so it's not going to be on this real graph. So we only have an arrow on this side. This 0, 0 is called my endpoint. Okay, so it's called an endpoint because you don't go any further than that. Okay, so this is an actual restriction that we have for this function. I can't go more negative than this. Okay, so if I'm looking at my domain, if my domain is a set of all possible x values, I look left to right. Okay, look at that graph. What do you think your domain is going to be?
0.
0 to what? Infinity. What goes on the 0?
The bracket.
A bracket. Good job.
Which
Okay,
one?
so
Why?
your range is your y. So where do you look
No.
for your range?
Why do
Why do we use the
Oh,
bracket?
I'm so sorry. Why do we put a bracket? Because that point is included. That means it's equal to.
Okay.
I'm sorry.
No, it's okay. At least I was right.
Okay, so your range is y. If you're looking at your y's, then if you do least to greatest, you look at the bottom of your graph and you go to the top of your graph. Okay, so where is the bottom of my graph?
0.
0. And if I follow it, it keeps going upward. It's going slowly upward, but it keeps going upward. So do I have a restriction at the top? No, I have an arrow, so it goes to infinity. So we have a bracket there as well.
So they're both the same.
Well, at this, because it starts with my origin, that's why they're both the same. But it's not necessarily always going to be the same value. Okay, so if we look at f of x equals negative square root of x minus 1, and then outside of the radical, you have a plus 4. Okay, so I want to refresh your memory. When we did square root, we had y equals a parentheses x minus h squared plus k. Okay, and if we had a number for my a, what would that tell me? Say that number was 5. What would that tell me? I'd have what transformation? A vertical stretch. Okay, if I have something going on with my x, what happens here?
Okay.
It would move it left or right, and then this k would move it up or down. Okay, so with square roots, we're looking at y equals a times the square root of x minus h, and then plus k on the outside. The transformations are still going to be the same. You just now have a square root. Okay? So my parent function, we always start with that. That was our 0, 0, 1, 1, 4, 2, and 9, 3. And then I'm going to take another color when we do our transformation. We're building our transformation table. What is happening to my x? I should really put what in my table? X plus 1. Why is it a plus when my function has a minus?
Opposite.
X is always the opposite. X is a liar. Okay, so then for my y's, what do I put?
Y plus 4. Negative y plus 4.
Negative y plus 4. Y'all remember this now?
Mm-hmm.
Okay. All right, so I take my x's and I add 1. 0 plus 1.
1,
1 plus 1.
2,
4 plus 1.
5,
9 plus 1.
10.
Good. All right, my y's, I'm going to make negative, then add 4. So negative 0 plus 4. 4. Negative 1 plus 4.
2, 3.
Mm-hmm. Negative 2 plus 4.
2,
And negative 3 plus 4.
1.
1. We follow how I build that?
Mhm.
Okay. Okay, now I start at 1, 4, and I'm going down with my arrow to the right. So where is my endpoint? 1, 4. Okay, so the reason you have endpoint / inflection point is because on your worksheet, this is what it looks like. I wanted you seeing what you get, but also you have to know with a square root, you have an endpoint. There's that restriction, okay? With a cube root, you have an inflection point. So you have to know which one you're dealing with to circle the correct one. Okay, so the square root, I have an endpoint. It's where you start your table and then you keep going in the other direction onward. Okay, so now if my endpoint is at 1, 4, what's the domain for this graph? My parent function, I started at 0
1.
and I went onward. So here it's the x value 1 and then I go to infinity. Okay. Now, what happened with this graph as far as the direction goes compared to my parent function?
It went down.
It's going down. So if it's going down, then when I go bottom to top, where am I really starting?
To 10.
I'm going from negative infinity up till this point because I'm going down. Y'all understand that? My graph is going down. So even though it looks like I'm just going to level out to the right, I'm still going down to infinity. So I'm going to go from negative infinity until I hit my endpoint at 4. So your endpoint, the x value is going to be the number for your domain. The y value will be the value for your range because you have that restriction. Okay? Now, if we look at our transformations, what did that negative tell me?
Over x-axis.
It reflects over the x-axis. The x minus 1 on my function tells me it goes where? It shifts right 1 unit. And where else does it go? Up 4 units. Good. Okay. We good with that? So instead of just doing 2 more, I'm only going to do 1 more because you should know your transformations from it. Okay, you really just need to know your parent function and everything else should follow. Okay, so if we look at f of x equals 1/2 times the square root of x minus 3 plus 5. Now my copy of the notes is the full copy of notes, so you might have more examples, but for right now, this is all you really need. Okay. So my parent function, I start at 0, 0, 1, 1, 4, 2, and 9, 3.
X plus 3.
Shoot.
Okay, so tell me what I do for my x's.
X plus
X plus 3 because x is the opposite of. Okay, and what do I do for my y's?
1/2.
1 plus 5.
Good. Okay. So for my x's, I'm adding 3. So what are my x values?
3,
3.
4, 7.
Good. And then for my y, I take half of my y, then add 5. So half of 0 is 0 plus 5 is 5. Half of 1 is 0.5 plus 5.
5.
Half of 2
1.
plus 5,
6,
and then half of 3
1.5,
plus 5.
6.5.
Good. That 12 goes just a little bit off your graph.
Okay, wait.
Okay. So where's my endpoint?
3 and 5.
Okay. Look at your graph. Tell me what is my domain.
Domain's X, so 0 and right?
Where's your endpoint?
3.
3. So what's my
I was doing
domain?
the parent function. Oops. 3 and 3 infinity.
3 to infinity. Now this time I'm going up like normal. So what's my range going to be?
5.
5 to infinity. So only when you have a reflection will your range be negative infinity to that endpoint if it's going down. Now I could reflect it over the y-axis instead of the x-axis, and then it would make it go left. And so your domain might change then. Okay, so you just have to look at the direction of your graph. Okay, so what are my transformations? What does that 1/2 tell me?
Shrink.
It's a vertical shrink by 1/2.
Right 3.
Good.
Up
Shifts right 3 units and up 5 units. Okay. We good to keep going? All right. We're going to move on to cube root functions. Okay. So we've done y equals x squared. When we did f of x equals x cubed, our parent function was -2, -1, 0, 1, 2. And we would cube all of those. -2 cubed is -8. -1 cubed was -1. 0 cubed is 0. 1 cubed is 1. And 2 cubed is 8. And our graph would look something like this. Y'all remember that from chapter 5? Okay. What was in the middle? Do y'all remember? The middle of that graph. When your graph started to change direction, what did I call that? That was your inflection point. Okay. So with x squared, when we had y equals x squared, I showed you that your graph was a parabola. When we do y equals the square root of x, your graph looks like that. Kind of like half of your parabola on its side. Okay. Now, what is the relationship between x cubed and the cube root of x?
3.
They're also the operations that undo each other. So those are your inverse as well. Okay. So when we are looking at our x values, when we plug something in, we have to be able to take the cube root of that. So would it make sense for this one to have -2, -1, 0, 1, 2 when you take the cube root?
No.
No. Instead, what would I have?
Yeah.
Hmm.
Here.
Can I take the cube root of a negative? In your calculator, do the cube root of -1. It says -1. Because when you cube something, look at your graph. Look at your table for x cubed. You're taking -2 and multiplying it by itself 3 times to get that -8. So how do I undo x cubed? I cube root it. Okay? So if I have negative 2, negative 1, 0, 1, 2 cubed to give me negative 8, negative 1, 0, 1, 8, what do you think I can put here for me to cube root and get whole numbers? Can I take the cube root of negative 8? What does that give me?
2.
Negative 2. Can I take the cube root of negative 1?
Yes.
It gives you negative 1. Can I take the cube root of 0?
Yes.
What do you think my next two values are going to be? 1 and 8. Compare that to what just happened over here.
It's flipping.
It just flipped it. That is what an inverse does. Okay? So that's going to be your parent function table for the cube root of x. So this lesson, you have two functions, square root of x and cube root of x. So you have to know which parent function table goes with which. How do you know if it's a cube root versus a square root?
You see the 3 and the 2. Or you see nothing.
You see a 3 for a cube root. If there's not a 3, it's a square root. It's very easy to determine which one is which. So I should not have anyone give me the wrong function. Okay? So when I graph this, negative 8, negative 2, negative 1, negative 1, 0, 0, 1, 1, and 8, 2, it looks like that. So it looks like, bless you, x cubed, but on its side. That's because all inverse functions reflect over y equals x, which we will have a lesson later on in chapter 6 all about inverse.
Yeah.
Okay? But for right now, you just need to see that this is what your parent function looks like. So do I have an endpoint?
No.
No, I have an inflection point. So my inflection point is at 0, 0. So if I don't have a restriction, what's my domain? Do I have a restriction on the left? No. Do I have a restriction on the right? So how do I write my domain? Negative infinity to positive infinity. Okay, now if I look bottom to top, do I have a bottom boundary? No, I have arrows. Do I have a top boundary?
Oh.
No, I have arrows. So what's my range?
Negative.
Negative infinity to positive infinity. Okay. So if I have f of x equals 2 times the cube root of x plus 3 minus 1.
I have a very too. Do you make up those problems like just as you go, or do you have them written down?
This one I just made up, but my
Wow.
other ones, like if you have more complex, I have the examples.
Okay, just have them wondering.
I don't have everything. Okay, parent function. I've got negative 8, negative 1, 0, 1, 8. And then I have negative 2, negative 1, 0, 1, 2. And I'm going to graph that. And then for my transformation, what do I do for my x's?
X minus.
X minus 3. It's the opposite of.
2 y minus 1.
Very good.
What about that 3?
Just 1.
This one?
That's the
So that is your function. That's your cube root. Okay, so be careful when you write that. Make sure that so the cube root that's part of my radical. Okay, just like how you have a square root, if I had a fifth root, I'd do the same thing. It's just part of it. It doesn't make it a transformation. Okay, because that's your index. So x minus 3, I take negative 8 and subtract 3. And get negative 11. Negative 1 minus 3.
-4.
0 minus 3.
-3.
1 minus 3.
-2.
8 minus 3.
5.
Good. Okay, and then 2y minus 1, I take negative 2, multiply it by 2, and you get
-5.
negative 4 minus 1 gives you negative 5, yes. And then negative 1 times 2 gives you negative 2 minus 1.
-3.
And then 0 times 2 minus 1.
-1.
1 times 2 minus 1.
Mhm.
And 2 times 2 minus 1.
3.
Sure. Do I have an endpoint or an inflection point?
No. Oh, inflection.
Inflection point.
Neither.
Okay, now your inflection point is where your graph changes direction. That's what we talked about. It was the middle of your graph at 0, 0 for your parent function. So where is it for my transformation function?
-3, -1.
Negative 3, negative 1. It is in the middle. And what's my domain?
Negative infinity, infinity.
Good, bless you. And then my range?
Negative infinity, infinity.
Now my transformations, what's the 2? The vertical what? Stretch. By 2.
Shifts left 3.
Good. Shifts left 3 units.
And down.
You good with that? Alright, our last one that we're gonna do. If I have f of x equals, let's say 1/2 times the cube root of negative x plus 5 minus 1.
Can the x be negative?
Mhm.
Oh. What the?
So we still have to recognize it's a cube root. So it's still gonna be my parent function, -8, -1, 0, 1, 8. And my y,
-2, -1, 0, 1, 2.
okay, when I go and do my x's for my transformation, we know that x is opposite of for this part. If you have a negative on your x, negative always means what? Like if I have a negative out here, what does that mean? It reflects over which axis? X. Okay, so if I have a negative right here, I still have a reflection, but now it's going to be over the y axis because you're taking these x's and you make them negative, so it flips over the y. Okay, so when you do your header, that negative stays, but the +5 is what you're going to change to be -5. And then my y's, I would have
1/2 y minus
So my x's, I have a negative 8, which means positive 8. Positive 8 minus 5 is
3.
3. And then I have a negative 1, which means positive 1 minus 5. Negative 0 minus 5.
-5.
Negative 1 minus 5.
-6.
Negative 8 minus 5.
-13.
Okay, and then we're going to take half of our y's and subtract 1. So
Zero.
half of -2 is a -1 minus 1. Gives me a -2. Then you take half of -1,
0.5.
-0.5.
Oh.
Minus 1 would be a negative,
1.5.
okay. Half of 0 is 0, minus 1.
-1.
Half of 1,
0.5.
0.5.
minus 1.
-0.5.
Mm-hmm. And then half of 2,
1.
minus 1. So you've got 3, -2. -4, -1.5. -5, -1. -6, -0.5. 13 is going to be off your graph at 0. -13. Okay, so do I have an endpoint or inflection point?
Inflection.
The middle, -5, What's my domain
-∞.
in my range?
-∞.
Okay, so if I do my transformations in order, that 1/2 tells me it's a vertical shrink by 1/2. That negative x, I told you it's a reflection over which axis?
Y.
Okay, so when you have your reflections, whatever variable it's on, it reflects over the opposite axis.
Shifts left.
And
Down 1.
okay, so y'all good with that?
This one.
Do you have questions?
No.